personal finance practice problem using OneNote. Present value and future value using tables. Get ready because it's time to get financially fit by exercising personal finance. Here we are in OneNote. If you have access to OneNote, would like to follow along, you're not required to, but if would like to, we're in the icon on the left-hand side in the Practice Problems tab, down in the 1114 Present Value and Future Value Tables tab. Also note, when using OneNote, look at the Immersive Reader tool. Our presentations will also be in the text area with the same name, same number, but with transcripts. Transcripts that can be translated into multiple different languages and either listened to or read in them. Closing the icon, we got our information up top, calculations on down below. We're continuing on with the present value and future value calculations, this time focusing in on the calculations of the format using tables. We're going to review what we have done thus far so we can see the different kind of components and ways that we could do the same calculation. So our information up top, we're going to assume the value of the property is increased at a rate per year of 7%. That then could be some type of investment generally. Could be land, could be a house, could be your savings account, could be stocks that we're assuming are going to go up at the 7%. Then we're going to ask how long before the property value doubles, which we can think of abstractly without even knowing the dollar amount of the original investment. And we could use, say, the rule of 72 to figure that out. But most people, I think it becomes more solid if you then come up with an investment amount and assume then how long it will take to double. Would mean that if the starting point was $1,000, doubling would mean when will it get to $2,000? 1,000 times 2. If we use the rule of 72, we can take 72 divided by basically the interest rate, but not in a rate or decimal format. So in other words, if it's 7%, we just divide by 7. That would give us an approximate answer of the 10.29 years. And note, we don't have any investment there. That's just going to give us the information no matter what the investment is. We also calculated it with a running balance, this being highly useful no matter what other method you use. It's hard to do if you don't have Excel, but Excel and other spreadsheet programs can easily put this together quite quickly, even if you have a long set of periods to work out. Gives you a lot more context. Then we looked at the tables, or the Excel functions, including the present value function, the future value function, and the net present value, these being related functions, each of which we can use in a similar way as using algebra, reworking them in essence to figure out the unknown to get to the more accurate answer, 10.24, this still being an estimate because the decimal is actually longer than that. Then we look at it with mathematical calculations, something that is the first kind of way you probably learn it in a course if you're taking like a finance course or something. And it's useful to know the function, but it's also something that you're probably not going to use as much in practice because you're going to start to use the functions in Excel as opposed to the formula. You're probably not going to be working it out mathematically so often unless you're taking a paper and pencil test. Then you're going to be using some of these other type of methods oftentimes. But the formula helps you to rework things algebraically and see how you could rework them algebraically. It's also a nice insight to that use of the goal seek and how that goal seek functions within an algebraic formula. And it shows you the relationship between the present value and future value calculations. Now we want to do the same thing with the tables. Now, when you think about the tables, note that the tables were really useful before like financial calculators were something that were around all the time because it allows you to line things up in a table, making it a lot more quick to do the calculation than it would be if you had, say, the formulas to work out, especially if you have multiple calculations to be done, and it would be quite useful in that format. These days, of course, we do have financial calculators and we do have Excel, which to some degree in practice means the tables are less useful. However, tables are still around and will still be used, especially when you're in courses in school, because they may want to remove the financial calculator, not make you do everything mathematically for more complex problems, but still want you to basically use the tables to basically figure it out. So it's kind of an in-between zone between having to do the actual algebra and using the tables. Now, just like we saw when we did the algebra up top, we're using the present value and future value calculations to kind of back into the number of periods, the unknown. So if I use this equation, I'm looking for this n. So I'm kind of solving for everything, solving for n. When you look at the tables then, it's a similar kind of thing. You might think, well, the tables aren't designed to figure out n. The tables are designed to help me to figure the rate so I could figure out the future value and present value. But we can kind of back into it in a similar fashion with the tables, and it's quite common to see a problem like that when you're doing test questions. So also note that with the tables, when we think about these categories of present value and future value, you want to think about basically 4 categories, 2 for the present value, 2 for the future value. So you have present value of 1, and you have present value of an annuity. When you're thinking annuity, you're not just thinking of a singular kind of amount that's affected by interest, but rather multiple kind of series of payment amounts that are taking place. And then you have the future value, which would be a singular amount or the future value of an annuity. So you have a singular and an annuity for the 2 categories of present value and future value. So for this case, we're not using annuities. We can use either the present value or future value tables to kind of back in or approximate the number of periods, just like we did mathematically up here, just like we did with the functions in Excel. So let's first look at this table for the present value table. Present value of 1, not an annuity. On the top column, we've got the percentages. On the side column, we've got the number of periods. Now, note that oftentimes we think of the percents as yearly percents. What you want to get in mind, however, is that it doesn't necessarily have to be a yearly percent, although the yearly percent is what we hear typically by default. So in other words, even if someone's talking about something that's a monthly payment, like a mortgage payment, and they're talking about the interest on the mortgage, then they're usually going to say, if they say 6% interest rate, the 6% generally means per year, even though we clearly know the payments are going to be made per month. Why are they using the yearly interest rate? Because that's the convention to use. And the yearly interest rate will typically be between 0 and 100. Whereas if we used a monthly interest rate, then we're going to be talking about interest rates that will often be quite small, difficult to communicate verbally, not difficult to use when you have computers and whatnot. So just realize that the rate up here needs to tie into the number of periods. Now, the period on the left-hand side, we often think of as years, but doesn't have to be years. It just depends on how often we're compounding things. So in our case, it will be years, but just realize that you can use this table assuming that the periods are 6-month periods, like you might see for a bond, or monthly periods. But just note that whatever the periods are, years, months, semi-annual, you have to have the rate that will match that period. And the smaller the period, the more likely the rates will not be as useful, or the table will not be as useful, because the rates will be either uneven and or too small for the table to kind of capture. And that's one of, again, the limitations that we have with the table. So in our case, we've got the 7% here. And if we're looking at the present value type of tables, we're imagining that we had the future value that we're trying to pull back to the present. So we're going to imagine we know what the future value is. It's double what the present value is, right? With the present value is 1,000, the future value would be 2,000, and we want to multiply it times something that would bring it back to the present, which would be the 1,000. So so that would mean that we would multiply it times something that would be basically 0.5 that we're looking for. So in other words, we're looking for this column 7%, and then we'd be looking for the rate that is around 0.5, which would bring us back from 2,000 to the present, which would be 1,000. Note that we're basically backing into this problem. We're kind of using the table backwards, in essence, in a similar way as reworking the algebra, solving for the unknown. But this is a common type of question you might see on a test. So you'd have the 1,000. So we got the 7%, and sometime between periods 10 and 11, you could see that it goes from at the 0.5083 to the 0.4751. So sometime between 10 years and 11 years, we would assume to be the number of periods for this thing to basically double, or, if it was the 2,000 if it were double to basically be cut in half, right? And that's, of course, our answer. As we saw up top, the 10.24 is the more approximate answer. So we can only get an approximation there because of the limitations of the table here, because the table doesn't have decimals in it and whatnot. These are limitations of the table. We could do a similar type of calculation if we look at the future value table. And so in the future value, what we'd be assuming is this is our starting point, 1,000, and we would want to multiply it times something that we would typically get to from the table to get to the ending point, which in this case we know is 2,000, double of the 1,000. So what would we need to multiply 1,000 by to get to 2,000? We'd have to multiply times 2 because we're doubling it. So we would want to be in the 7% column again, and we're looking for the number that would be 2 here so that we can find the related period to see the number of periods to basically double this thing. So if we're at 7%, we can go down here once again, sometime between 10 and 11, we go from 1.9672 to 2.1049. So we can determine from the table that it will double somewhere between 10 and 11 years, which is the same thing we got up top, which of course is similar to the answer of the 10.42. So that's how we can use the tables. The tables, like I say, if you're working in a school setting, then the tables can still be relevant. The tables are not quite as relevant, or generally not relevant generally if you're doing your own calculations in practice, because I would think that the best thing to use would be sitting down at a computer, using the spreadsheets, using your functions, making running balanced tables so you can better understand what's actually going on with the calculations you're doing.